For, well, as long as humans have been around, this silent, cosmic fire has been dancing across our polar skies. We're talking about the aurora, of course. It's a phenomenon that has inspired awe, fear, and a whole lot of wonder all at the same time. So, in this explainer, we're going to trace its whole story, from ancient myths to a storm that literally changed the world, and finally get into the incredible science that makes it all happen. To really get a feel for the sheer power of the aurora, you just have to hear it from someone who is actually there. This is from the log of a ship, the Messenger, back in 1859. They were caught right under the lights during this massive, massive storm. The writer just says, "A blaze of crimson. I have not the language to describe it." That feeling right there, that speechless awe, that's the perfect place for us to start this whole story. So long before we had any science to explain what was going on up there, Asian cultures, well, they had to figure it out on their own. They had to make sense of these incredible light shows. And, their interpretations were every bit as varied and as vibrant as the lights themselves. And what's so fascinating is how different these interpretations were. I mean, it's a total contrast. For some people, these lights were a sign of pure hope. The Norse myths, they saw reflections from the Valkyries' armor, as they were leading heroes to Valhalla. The Algonquin tribes believed it was a comforting fire, lit by their creator, Nanabojo. But then, for others, these lights were absolutely terrifying. The Sami people in Scandinavia thought they were the souls of the dead. And get this, they believed that if you teased the lights, they could actually reach down and snatch you away. And the Fox Indians, they saw them as vengeful spirits of their enemies, coming back for revenge. So you've got the exact same spectacle in the sky, and it's either a divine blessing or a terrifying omen. This really deep connection, you can see it right in the names they gave the aurora. I love this stuff. In Norse mythology, it was the Bifrost Bridge, that glowing, shimmering path to Valhalla. In Finland, they call it Reventule, which means fire fox. That comes from this amazing myth about a giant Arctic fox running across the snow and whipping up sparks with its tail. So cool. And even the Scottish nickname, the Merry Dancers, it sounds kind of cheerful, right? But it actually refers to warriors locked in an epic, eternal battle up in the sky. So you might be wondering, how far back does our recorded history with the aurora actually go? Well, the earliest potential sighting we've found comes all the way from China. We're talking about the Bamboo Annals, these ancient court records, and in them there's a description of a mysterious five-colored light that was seen in the northern sky. Scholars have dated this to nearly 3,000 years ago. That just goes to show how long we've been looking up and trying to figure this all out. For centuries, the aurora was pretty much a regional mystery. It was a spectacle for people living way up in the far north. But then came 1859. And in 1859, a storm of just unimaginable scale brought these lights to the entire world. And when that happened, well, it started to change absolutely everything. This event, which we now call the Carrington event, was actually two storms, one right after the other. It kicked off on August 28th with a really huge aurora. Then, a few days later, on September 1st, an English astronomer named Richard Carrington is just doing his thing, sketching sunspots, when he sees this brilliant flash of white light just erupt from the sun. And only hours later, the energy from that solar flare slams right into Earth, triggering a second, even more spectacular global aurora on September 2nd. Just incredible timing. And the intensity, it was just staggering. We're not talking about a faint glow in the distance. No way. The sky was so brilliant that newspapers at the time reported that people could read a book at 1 in the morning just by the light of the aurora. And get this, some gold prospectors out in the Rocky Mountains were woken up by the bright light, and they actually thought it was dawn and started making breakfast. That's how bright it was. And people who saw it from as far south as Cuba and Australia, they described the sky as being a deep blood crimson red, not the green we usually think of. Now, seeing a red aurora is incredibly rare, especially that far from the poles. This photo here gives us a little taste of what that must have looked like. The entire sky just seemingly on fire. You can totally understand why so many people thought it was the end of the world. But this storm wasn't just a light show. Oh no, it had a real physical impact. You have to remember, at the time, the most advanced technology on the entire planet was the telegraph, and this storm completely crippled the global network. We're talking all 125,000 miles of it. I mean, this was a real physical force we're talking about. telegraph operators were reporting getting electric shocks right from their equipment. There's this one legendary account from an operator named Frederick Royce, who was stunned when a spark of fire literally jumped from his forehead to his machine as he leaned in. Can you even imagine? Okay, and this is where the story gets really, really weird. The atmosphere was so charged with electricity that telegraph operators figured out they could completely disconnect their batteries and keep sending messages. They were powered only by the auroral current. Think about that for a second. This was a stunning revelation. It was the first real proof that the aurora wasn't just light in the sky. It was fundamentally an electrical phenomenon. So the Great Storm of 1859 proved there was a connection between the sun, the aurora, and electricity here on Earth. But figuring out how it all actually worked, well, that was a whole other puzzle. It would take another 50 years and the absolutely relentless vision of one particular scientist. And that scientist was Christian Birkeland, a Norwegian physicist. In the early 1900s, he came up with what was, for the time, a pretty radical idea. He suggested that the aurora was caused by streams of charged particles flowing from the sun. Now, the scientific establishment, they pretty much dismissed him. They thought it was crazy. But Birkeland was absolutely determined to prove he was right. So here was his central theory. He proposed that these particles from the sun don't just hit us randomly. No, they get captured and guided by Earth's magnetic field, almost like beads on a wire. And that magnetic field channels them down into the atmosphere right at the poles. It's there, he argued, that they smash into the air and create the lights. Today, we honor him by calling these pathways Birkeland currents. Now, to prove this theory, he didn't just write papers. He built this incredible machine he called the Terrella, which basically means little Earth. It was a magnetized sphere, just like our planet, sitting inside a vacuum chamber, and then he fired beams of electrons at it. And amazingly, he created a miniature aurora right there in his lab. You could literally see these glowing rings forming around the magnetic poles of his tiny model planet. What a genius. Birkeland published his big theory back in 1908, but sadly, even with his amazing Terrella experiments, he died in 1917 with his work still largely unproven and not really accepted by the mainstream. It's a bit tragic, really, but the story has a happy ending. It just took another 50 years. At the dawn of the space age, in 1967, a U.S. Navy satellite finally flew over the poles, right through the exact regions he had described, and it directly measured the magnetic disturbances, confirming those currents were real. He was right all along. It just took half a century for technology to catch up with his brain. Okay, so Birkeland finally proved the connection between the sun and the aurora. But that still leaves a big question. What is actually happening up there in the atmosphere to create that incredible dancing light? All right, let's break down the science. It really all comes down to 4 key steps. Step 1. The solar particles arrive, and they're funneled down to the poles by Earth's magnetic field. Step 2. These super high-energy particles smash into the atoms in our upper atmosphere. We're talking mostly oxygen and nitrogen. Step 3, that collision transfers a bunch of energy to the atoms, and it puts them in what scientists call an excited, unstable state. And finally, step 4, to get back to their normal, stable state, the atoms have to release that extra energy. And how do they do that? They spit out a photon, a tiny particle of light. And when you have billions and billions of atoms doing this all at once, that's the aurora. So, what about the colors? Why isn't it just one color? Well, it all depends on 2 things: what kind of gas gets hit and how high up that collision happens. So when those solar particles hit oxygen at lower altitudes, say between 60 and 150 miles up, we get that brilliant classic green color that we see most often. But if they hit oxygen way, way up high, above 150 miles where the air is super thin, that's when you get that rare all-red aurora, like the one they saw back in 1859. And if the particles hit nitrogen atoms at even lower altitudes, that's where you get the beautiful blues and purples. And the quantum physics behind why we get red and green is just wild. It's produced by something called a forbidden transition. That sounds mysterious, but it just means it's a really slow, unlikely way for an atom to release light. Think of it like this. To make the green light, the oxygen atom has to hold on to that energy for almost a full second before it can let go. But for the red light, it's even more forbidden. The atom has to hold on for up to 2 minutes before it can finally release that single red photon. Now, this can only happen at super high altitudes where the air is so thin that other atoms won't bump into it and interrupt the process. And that's exactly why you always see the red aurora appearing above the green.
So we've gone on this whole journey, right? From ancient myths all the way to modern quantum physics. But the story of the aurora, it's not over. Not by a long shot. In fact, understanding it today is probably more important than it has ever been.
I mean, just think about it for a second. Back in 1859, the most advanced piece of tech was the telegraph, and the Carrington event brought it to a total standstill. Now, fast forward to today. Our entire world runs on this incredibly delicate web of technology. Power grids, GPS for everything from our cars to our phones, thousands of satellites controlling communication, finance, even defense. And every single bit of it is vulnerable to the very same solar energy that lights up the sky. And that brings us to the final and frankly kind of scary question. A storm on the scale of the 1859 event happens, on average, about once every 1 to 200 years. Well, we're well within that window right now. That last big one crippled the simple telegraph. So what happens when the next big one hits our modern, hyper-connected world? It's a sobering thought, isn't it? It kind of takes the aurora from being just a beautiful light show right back to what it was for our ancestors, a powerful and maybe, just maybe, a fearful omen.